do some examples. There's not much to this. Once you know the derivatives, I don't really know what else to tell you. Go find it. F of x is equal to 3 times secant of x. Its derivative, well, we already know our constant multiple rule, which tells us the 3 is just going to hang out. Now we just need to multiply it by the derivative of secant. Now the derivatives of secant and cosecant, they both have themselves inside their function. Inside their derivative, I'm sorry, I misspoke. And so this will be, let me see if I can zoom in, maybe that'll help. Secant of x, tangent of x. You get right into there. And that's it. That's it. And another way to help with secant's derivative, like, don't we have something like this? This isn't a derivative, this is a trigonometric thing, like tangent squared plus 1 is equal to secant squared. Remember that one from trig? Yeah, because secants and tangents go together. Cool, just thought I'd throw it out there. Same thing with cosecant, derivative of cosecant, negative cosecant cotangent. And there's a Pythagorean identity with cosecant and cotangent. It's like it's all tied together. It is. Here we go. Got a new one. We got a function times a function. We got a, maybe we can say there's an f, there's a g. We could jump aside and be like f and g, set that shit up. Remember that game I was showing you, like that? Whenever you got a product, you can kind of do one of those. So let's write it in. So our f is x squared, and then its derivative is 2x. We're like, we got a sine of x is our g, so we're like, sine of x, and its derivative is cosine of x. We'll just make yourself a little plus sign right here, just a little x, I guess you should say. And let's write it down. I think we got it. So let's just say that y prime is going to be what's that? The x squared times cosine of x. So x squared cosine of x plus 2x times sine of x. And maybe you want to clean that up a little bit. Take the x out. Just leaving you with x times cosine of x plus 2 sine of x. Not so much to it. It's the same stuff. But now, power rule, quotient rule, product rule, all of these things are now building into something larger. You have more games to play. Let's keep going. I look at this one and you're like, is this a quotient? And it could be, if you want to. If you'd like it to be, it could be a quotient. But shoot, we could. I don't know about you, but I prefer the product. Maybe we just say it's cosine of x times x to the negative third. And we could just do product rule again. I don't like to do the quotient rule if I don't have to. If I could do product rule all day long, I'm going product rule. All day long. So again, maybe we just do this f, we call this one g, and we'll do that same trick. And I'm not going to write everything. Let's just say cosine of x, and its derivative is negative sine of x. Our next one, we get that it's x to the negative third, so the negative 3 falls to the front. We subtract 1. There we go. Now just do your little... Oh shit, both things are going to be negative. Oh my gosh. Oh my gosh. All right, so y prime, or actually this time, you know what? Stop writing y prime. Let's go dy dx. Let's show them what's up. Let's get nerdy. So let's put a negative sign. So the negative, I'm going to go negative x to the negative third sine of x. And then minus, what's that? Negative 3x to the negative fourth cosine of x. Yeah, that's cool. That's cool. I want to show you that it would turn into like a quotient. That it would look just kind of like what the quotient would look like. Just to show it. So we got our negative sine of x all over our x cubed, and then we're going to have a minus 3 cosines of x over x to the fourth. So to create a common denominator on this bad boy, if we were to go and mess around, you know, just kind of give it another x. We'll call it to the fourth, and we give it an x right here. Common denominator. Now we're ready to rock. We put this stuff together, and what are we going to end up with? I think we're going to get negative x sine x minus 3 cosines of x over x to the fourth. Shoot, I don't know if that's the same thing. Can I check it? I got to check it. I don't want to have to run the whole thing through. I'm sorry I lied to you that it was a product. So let's see if we can't do this in another way. Let's say our dy dx. Let's see if the trick I showed you would actually be useful. So low times the derivative of high minus high times the derivative of low. Square the bottom. Cool. Hey, do you see anything in common here? These x cubed and x. So we mind if we take an x squared out to the front? It'll leave us with negative x sine of x. Minus, what's that, 3 cosines of x? I think that's minus 3 cosines of x all over x to the 6. So what happens when you take away 2 from 6? This thing's going to go away, and that's going to turn into a 4. So I wonder if this is the same thing. Oh, shit. They are the same thing. They are the same thing. Just wanted to go through and show that there's more than one method. Find what works best for you. Don't think of this stuff as you didn't need to do any of this extra crap. I'm just showing you. Maybe there's a method that's simpler for you. Find your path, not my path, not the book's path, not the homework's path. You really want to understand this. You really want to make this shit easier on yourself. Start finding little patterns. Start finding, I prefer this. So you don't show up to a freaking test and go, I don't know what to do, because you're only doing one section at a time. You're not doing all of it at once, not knowing that which section, or like, oh, am I in the product rule or am I in quotient rule section? It doesn't matter. You're supposed to be able to know all of them. So start getting these tricks and be like, dude, I prefer product over quotient. Maybe you're in this next thing I'll show you in 3.4. Maybe you're like, a product in a chain is my way to go. I don't know you. Hope to. Okay. Let's go. Go to another one. I'm starting to go off, getting a little fired up. I don't know what's going on. So let's say if f of x was equal to, wow, secant of x. Let's go find f double prime and pi over 4. Now this is where you're going to start seeing that your teacher's kind of an asshole about this stuff, because maybe not this one, but soon, like our next, you'll see some equations, tangent lines, and horizontal stuff. You're going to have to start solving trig equations. Probably one of the most challenging things from a trigonometry class. So if you haven't got your practice, you're going to get it. So let us go. We'll take our derivative on secant, and that's going to be, what was that again? Secant x tangent x. Now let's take a second derivative. But if we take a second derivative on this, we have a product, right? We have ourselves a product. So I'm going to do it a little different this time. Well, actually, nah, screw. We got our secant, and we got our tangent. There's our f and our g. We'll take our derivatives. Put them underneath. The derivative of tangent secant squared, the derivative of secant and secant tangent. Put that stuff together. So secant times secant squared, that must be secant cubed. Plus, now we got secant of x, tangent of x times tangent. So that's what? Secant of x, tangent squared of x. Oh, hallelujah. We found our second derivative. Everybody's freaking happy. But now we got to take that pi over 4. We got to plug it in for all of our x values, huh? Because that's what we're looking for. That's why we went to the second derivative. So we go f double prime of, and we're going to pop that pi over 4 in everywhere we see it. So we go secant cubed of plus secant of times tangent squared of, and we pop that pi over 4 into there. And we're all familiar. We know. Come on. So something cubed plus something times something squared, because that's how it works. Those little cubes and squares, just they take the whole thing and square it. So secant of pi over 4, I know cosine of pi over 4 is equal to root 2 over 2. Hence I know that secant of pi over 4 must be equal to 2 over root 2, which actually reduces down to just root 2. I'll let you figure out why. Secant of pi over 4 will still be equal to root 2, and tangent of pi over 4, that's where sine and cosine equal each other, so that must be equal 1. So what do we get here? 2 root 2's? Yeah, that's what we get. Plus root 2? Well, shoot, I think our answer is 3 root 2's. Man, I like a problem like that. You actually got to know some values. I'd probably take you a step further, because you might be able to calculate your way out of it. The problems I like to give, I make sure that the calculator doesn't really help for shit. We'll mess around with those in the next one, and we'll play just a little bit of a different game, too. All right, see you soon.